No, yeah, the environmental DNA, I think, is it's full of potential, I think, and is really exciting. So basically, using water, either from fresh water or seawater, and filtering that water. I think for fresh water it was only 15 milliliters, so not a lot. They have found traces of different fauna, even otters, I think, so which are mobile. They don't stay in a single pond, they move. And I think that's really fascinating, and with a lot of applications in monitoring, yeah, as they point out in the paper. Like if you need to monitor an endangered species of amphibians, for example, that are nowadays so threatened both by climate change and pollution, you can use that technique to really monitor different ponds or different rivers, and I think that's really nice. And they point out in the paper as well that they have compared ponds where they have done traditional surveys with really highly skilled scientists or biologists, and they compare the results with their DNA results. And even some of the ponds where some of the species were not surveyed by the trained and skilled biologists, those ponds were, when they were surveyed by DNA, they found traces of the species. So yeah, I think it's really nice, and hopefully they can apply it to sea animals and algae. They have published another 2 papers on that technique in seawater. So you need a lot more starting material, but they have found fish. Like one of the papers was on fish diversity. They have found, I can't remember on the top of my head, but around more than 10 different species. And they related that also with transects of experts looking for fish abundance, and they did another one looking for a harbor porpoise DNA close to a pond where they had harbor porpoises in captivity. So they measured the water like at 500 meters, 1 kilometer, and they are also really exciting papers, I think.